All right, we're going to look at the combined gas law today. What the combined gas law is that it looks at all three variables at the same time. So it looks at pressure, volume, and temperature all in one equation. So what it looks like a combination of all the three gas laws that we've covered. So we're going to have P1 times V1 over T1 equals P2 times V2 over T2. Okay, so when looking through a problem, you want to kind of indicate what variable is what. Okay, so a gas has a pressure of 150 kPa, that's your P1, the first pressure, a volume of 25 liters, that's V1, and a temperature of 120 Kelvin. That's in Kelvin, so we don't have to do any conversions here. What will be the new temperature, meaning what's going to be the T2, if the volume changes to 50 milliliters, so new volume V2, and the temperature decreases to 95 Kelvin, so our new temperature is 95. Okay, so what the setup is going to look like here, we're going to plug in our numbers into the equation. 150 kPa, pressure, volume, 25 liters, over the first temperature, which is 120 Kelvin. That is equal to the new, oh, you know what? We're going to change this. Never mind. They gave us the temperature. This is a typo. They meant to say pressure here. There we go. This one's actually looking for the new pressure. That should have had the word pressure in there. So we don't know P2. The new volume is 50 liters, and the new temperature is 95 Kelvin. Okay, so this is still going to use cross multiplying. It's just we have a bigger set of numbers we're working with here. So the first set, we have 150 times 25 times 95 as one set. And the other set, we have 50 times P2 times 120. Okay, so when you're doing cross multiplying with a combined gas law problem, you want to multiply the set of numbers that doesn't have the unknown variable in there. In this case, these three numbers. So 150 times 25 times 95. Okay, so that's the answer for that part. And then the other two numbers, we're going to divide by those two numbers to get P2 by itself. So whatever numbers end up with one of your variables, you're going to divide by those numbers. So we're going to divide by 120 and by 50. So we get 59.4 about. So P2 equals 59.4, and P2 the unit, well, P1 was kPa, so P2 will also be, for pressure, kPa. All right, let's try another one. Okay, chlorine gas is held under 3.5 atm of pressure, so that's your P1. Volume is 80 liters, V1, and the temperature is 110 degrees Celsius. Okay, right away I can see that I'm going to have to add 273 to that to get it into Kelvin. So the T1 we're going to have is 383 Kelvin. Okay. The pressure is changed to 4.8 atm. That's the new pressure. Temperature increases to 150 degrees Celsius. So that's your T2, but again, we're going to have to add 273 to that to get it to Kelvin. So that would be 423 K. It's asking what's the new volume. So our V2 is our unknown here. All right, so let's plug in our numbers into the equation. So P1 V1 over T1 equals P2 V2 over T2. So P1, 3.5 atm times V1, 80 liters, over T1 in Kelvin is 383 Kelvin. That is equal to your new pressure. They gave us a new pressure of 4.8 atm. Volume 2, we don't know. We're going to solve for that. Over the new temperature, T2 in Kelvin is 423 Kelvin. So just like the previous problem, we're going to kind of outline our cross multiplying here. Again, we're looking for the set of numbers that does not have the variable. So these three numbers, so we're going to multiply those. 3.5 times 80 times 423, and then press enter. Okay, so now the other set of numbers, the 383 and the 4.8, that's with our unknown V2, we're going to divide this big number we got by those two numbers. So divide by 383, divide by 4.8, enter. So your new volume is 64.4 for the unit. V1 was liters, so V2 will also be liters. All right, one last one. Sample of laughing gas has a pressure of 120 millimeters mercury, P1, volume of 32 liters, V1, temperature 55 degrees Celsius. Now that's Celsius, so we have to add 273 to that to get it to Kelvin. So that would be 328 Kelvin. What will be the new pressure? We don't know P2. If the temperature decreased to 20 degrees Celsius, T2 Celsius, we got to add 273 to that to get it into Kelvin, which would be 293 Kelvin. And the volume increased to 40 liters. That's your new volume. Okay, so let's plug our numbers into the equation. P1, 120 millimeters mercury, times V1, 32 liters, over T1 in Kelvin is 328 Kelvin. That's equal to our unknown pressure, P2, times our new volume, 40 liters, over our new temperature, 293 Kelvin. Okay, so now we're going to set up our cross-multiplying work. So the set of numbers that does not have the variable are these three numbers. So we're going to multiply those three. 120 times 32 times 293. All right, so there's that big answer. The other set of numbers with the variable, we're going to divide by those two numbers. So divide sign 328, divide sign 40. Enter. So we get 85 point, we'll round that up to an 8. So 85.8, this is our P2, and our unit here, P1 is millimeters mercury, so P2 will also be millimeters mercury. That's it.